Namaste, Dandavat Pranam. We are very happily gathered here today to read chapter 3 of Idols of the Mind versus True Reality. The title is The Unreasonable Effectiveness of Mathematics and the Natural Sciences. We humbly request anyone who is watching the live stream or any of the participants, any of the devotees here, as we go along, if you can write down any comments that you may have or questions or any points for discussion. This way we can smoothly move into that at the end of the reading and also next week when we have the full time for discussion. So I will share the screen so you can read along if you like. The identity of indiscernibles. Leibniz's principle of the identity of indiscernibles states that there cannot be separate objects that have their properties in common. Thus, one and any other one in mathematics being exactly identical cannot refer to physical objects. No two objects in physical nature are exactly identical. Thus, mathematics has a different logic than nature. As Wigner implied in his Unreasonable Effectiveness of Mathematics and the Natural Sciences, it would be unreasonable to think otherwise. That's Eugene Wigner. Counting one apple, two apples, and so on is not the same process as counting numbers, 1 + 1, etc. First, we note that all ones are exactly identical in arithmetic, but no two apples are identical in physical nature. When we count apples as if they were identical entities, we are not referring to actual apples, but a notion or sortal we call apple. This distinction is generally ignored. The point is that counting numbers in mathematics and counting physical objects deal with different entities. Galileo's error of primary and secondary properties. Galileo Galilei proposed that mathematics was the language of the book of nature, innovating the use of mathematics in what has become modern science. What is usually not explained is that Galileo had a particular view of reality that made this seem possible. His perspective was that physical objects had what were called primary and secondary properties. Primary properties were quantitative, such as size, weight, and so on. Secondary properties were qualitative phenomena, such as taste, color, and so on. These secondary qualities belonged to the sensory organs perceiving physical objects, but not to the objects themselves, which possessed only primary properties. Thus, color, for example, was determined by the sense organs of a human being or other creature, and not by the object being perceived. Of course, that is not the way we understand physical objects today. Primary quantities and secondary qualities of physical objects are thought to belong to the objects themselves and not divided between the two observer and the observed. Some have interpreted this to mean that Galileo thought that phenomenal qualities belonged to consciousness and quantities to physical objects. However, it has been claimed that he meant the sense organs rather than consciousness, although it may be argued that the sense organs do not sense anything without consciousness. The intact organs of a dead body do not sense anything when life or consciousness is missing. The problem with dividing sense perceptions from objects is, of course, that sense perceptions have to come from somewhere. One doesn't just experience some quality without its relation to the object whose quality it is. A more integral metaphysics is needed to heal the division that was promoted by Galileo and others. The mathematization of physical nature was based on a metaphysics that is divisive and incomplete. Physical development of ideas that science ignores. Descartes, independent thinker that he was, similarly held the dualistic view of qualitative and quantitative measures and forged the idea of the numerical nature of space and time. For him, mind and metaphysics was to be kept separate from the extended spatial physical world of matter, which is physics. Locke argued that objects characterized by size, shape, and so on could not be distinguished from a region of space of the same size, shape, and so on. Berkeley explained that primary qualities are determined by experience as much as an object's qualities. This undermined the whole metaphysics of Galileo and others, yet the dogmatic applicability of mathematics to science maintains a foothold in science to this day, without metaphysical critique. While Berkeley tried to bring the idea of the world into the subjective mind, Kant attempted to reinstate the denuded objectivity of things in terms of an abstract thing in itself that was unknown and unknowable, but logically posited by thought. Schelling furthered this historic development in philosophy by offering that the subjective and objective worlds were perspectives that were identical in their difference, thus overcoming the strict divide between them. Hegel then brought the whole development to an absolute conclusion by explaining that the idea of the world was not in a particular subjective mind alone, but there is also the idea of the objective world within which the particular observer is included. This leads to the necessity of a comprehensive absolute idea that has being in and for itself, in which both the particular, subjective, and universal objective perspectives are dynamic participants of a higher unity in difference that preserves yet sublates them in a negative self-conscious individual unity. From Pantocrator to chaos. Many other problems exist in applying mathematical mechanics to nature. Newton had to invoke a Pantocrator to correct for the unavoidable disastrous perturbations that the planets in the solar system would suffer in their journeys. The ancients believed that the planets followed ritual performances, or rita, but rejected the idea that they were being constrained by force like naughty children. From the history that we now call myth, we know in both the Occident, in the Western world, and the Orient, the Eastern world, that the ancients long held the planets were free spirits, rational personalities, and subject to laws, but not impersonal mathematical formulas. The problems created by mathematical mechanistic theories in cosmology have led to a crisis in the deterministic model that has ruled scientific thinking in the modern period. It has given rise to the theory of chaos that is now the reigning concept of the universe, which cannot simply be swept under the carpet by those who still support the doctrine of mechanistic science. In a 1986 speech, James Lighthill said, "We are all deeply conscious today that the enthusiasm of our forebears for the marvelous achievements of Newtonian mechanics led them to make generalizations in this area of predictability, which indeed we may have generally tended to believe before 1960, but which we now recognize were false. We collectively wish to apologize for having misled the general educated public by spreading ideas about the determinism of systems satisfying Newton's laws of motion that, after 1960, were to be proved incorrect." Many scholars agree that the argument for a clockwork universe is a strict consequence of Newtonian dynamics, which is no longer logically valid, although it is still held to be true by many in the general public and among many scientists. Due to complexity and errors accumulating exponentially over time, we cannot be certain of determinism during short intervals, in principle, or even for classical systems. Nature seems to draw a curtain on predictions of mechanical motion in a clockwork universe that is beyond our ability to unveil. Logic of mathematics compared to the logic of nature. Einstein once remarked, "Everyone who is seriously involved in the pursuit of science becomes convinced that a spirit is manifest in the laws of the universe, a spirit vastly superior to that of man, and one in the face of which we, with our modest powers, must feel humble." There should be a question mark between mathematics and nature because they deal with two different logics. During a speech given in 1921 at Berlin's Prussian Academy of Science, Einstein addresses this relationship. One reason why mathematics enjoys a special esteem above all other sciences is that its laws are absolutely certain and indisputable, while those of all other sciences are to some extent debatable and in constant danger of being overthrown by newly discovered facts. He then continues, it is mathematics which affords the exact natural sciences a certain measure of security, to which without mathematics they could not attain. At this point, an enigma presents itself which in all ages has agitated inquiring minds. How can it be that mathematics, a product of human thought, which is independent of experience, is so admirably appropriate to the objects of reality? Is human reason then without experience, merely by taking thought, able to fathom the properties of real things? In my opinion, the answer to this question is briefly this. As far as the laws of mathematics refer to reality, they are not certain. And as far as they are certain, they do not refer to reality. In other words, mathematics works within its own framework of certainty based upon a set of axioms of mathematics, thus yielding specifically determinable results. There is, however, no reason to expect that the reality of nature obeys such axioms, or that observations and experiences of nature should in any way correspond to the realm of mathematical logic. Thus, the employment of mathematics in science is more or less just to give scientists comfort and security, rather than any real or ontological connection between mathematics and science. Furthermore, Gödel did much to dispel even the certainty that mathematics falsely claimed for itself, and that's referring to Gödel's uncertainty principles. So far as the touted accuracy of quantum theory is concerned, it must be understood that even false scientific theories can give amazingly accurate results. In the past, the Chinese beat a gong to make the moon dog stop eating the sun god during a solar eclipse. The theory works flawlessly 100% of the time. That quantum mechanics works so accurately for a single electron or even two particles ignores the fact that as a mathematical construct, there is no such thing as a single electron or two in the universe. The accuracy of the whole theory breaks down when we consider any real-life situations without idealized approximations. It may be uncomfortable for scientists to think about these difficult but very real problems that afflict the very foundations of modern science, but it does not alleviate or eliminate such problems by ignoring them. Positively, they provide an incentive to rethink our conceptions of science, making not only the known, but also our knowledge of the known an object of study. This will raise science to self-conscious science, making the scientist in science, including the scientist in science, and change the method of science in the process. That's the end of this chapter. Are there any comments or points?
I love the fact that mathematics is certain, but all other sciences aren't, yet they were all created by thought. So I just find that very interesting that happens.
Yeah, what Maharaj is saying there is that, well, he's quoting from Einstein. That's a quote from Einstein, a talk that Einstein delivered at the Prussian Academy of Science. And what he was saying is that within its closed system, within mathematics as a closed system, it's certain because it's consistent within its closed system. But then when you make the claim that that closed, consistent logical system actually applies to nature, that's when the problem comes. And so what modern science does, the authority that it apparently has about being a very firm and reliable method to learn about nature, the claim of physics and chemistry and trying to do with biology is that it has mathematical precision. So that's why it's very it's accountable. You can trust that this is how nature is really going on because they've measured things and they've observed things with mathematical precision. But the whole point Maharaj is making is that mathematics, although it may be a logical and consistent system in itself, it is extremely questionable and in fact does not relate to nature for the one main point he raises at the beginning, called the identity of indiscernibles. That 1 + 1 logically means that you have one identity and then another same identity. 1 and 1, right? It means the same exact identity. And then you add them together and now you have a new identity. But now when you just take a very simple example of an apple, you take one apple and another apple, right? That's not 1 + 1 because each of the apples, they're two completely different things, even from a quantitative perspective. They have different masses, different weights, different shapes, different color, different taste even. Although they may be very similar, they're definitely not the same. They are not identical. So you can't say that that is 1 + 1 = 2 because they are not two identical things on a very simple level. So 1 + 1 does not equate to anything in nature because anything in nature is nothing in nature is identical to anything else.
Right.
We even had a talk, right, a couple of weeks ago with the cell biologist Brian Ford, and he admits even identical twins, right? That's the closest thing in nature that we can get to two things being identical in nature. And identical twins are anything but identical. They may look very similar, but they have completely different personalities, different ways of thinking, so many things. So there are no two things in nature that are identical to each other. And that's the very basis of mathematics, that you have these identities that are truly logically identical in that closed, consistent logical system. And that then the logical laws of how mathematics works develops off of that fundamental thing. So that's fine as a logical, abstract system, but that does not apply to anything in nature, actually.
Thank you. Even they say no two snowflakes are the same, and there's billions of snowflakes.
Yeah. So it's a very profound point, obviously, because I mean, everything in our modern society that is, technological advancement is based on mathematics, right? All physics is based on mathematics. So then we can wonder if mathematics does not actually apply to nature, but it's forcefully being applied to it, and then all these material results are coming, such as new technology and advancement from a certain angle of vision. What does that mean?
Mhm.
So we can understand that just because new technology is being created, that has nothing to do with us coming closer to the truth of reality, right? And that's not just some abstract philosophical point, but we can see that, do people know how to actually responsibly utilize technology, or is it really benefiting society and people's relationships with each other, or is it detrimental to those things because people don't know how to responsibly engage with these advanced technologies, right? There's a disconnect somehow, although society is supposed to be supposedly advancing technologically and all these things, people are in a worse condition. More mental health disorders are there, right? More mental health epidemic, they call it. So there's a huge disconnect. And Maharaj is pointing out this one very important fact, that mathematics, which is touted to be the supreme authority for determining truth, mathematical precision, that's not the case. So this is one of the ways that we can see where that disconnect may be coming from.
Thank you.
If anyone can speak to, like Devahuti Didi as an educator, or Rajagopal Prabhu as a software engineer, if you can speak to how the role of mathematics, just in your own life, what is the role of mathematics as you've come to know it, even through your profession, and then we can perhaps try to understand how to better integrate what Maharaj is presenting into how mathematics is utilized in the day-to-day, and from various educational, from the educational side, or from the utilitarian side of software engineering. We can talk about something like that. I think that may be useful.
Thank you. Well, we have different streams like PC and B earlier. Now it is CS with physics, CS with mathematics, like that they have done with the NEP policy coming into picture. So only two streams we are studying. The students are studying only two streams, computer science and mathematics. So right now they are studying the basics of mathematics and a little bit of advanced mathematics with the lab in mathematics. Earlier they didn't have lab, now they have mathematics lab. Of course, the use of mathematics in software engineering is a lot. Whenever we are doing software estimation, or when we are estimating the quality of the software, we use mathematics a lot. And it justifies, like without that, we can't go ahead in software engineering. So mathematics is very useful and it is needed there. But we are not seen from the perspective as to what you were now telling. Really got the point, and Maharaj has spoken all this time. We just see from the how computer science is like, computer science is a playground where all the computer science is actually going to be integrated with science, physics, mathematics, and it's like a playground where other subjects can be used. That's how we view mathematics.
As Maharaj has mentioned many times, that of course mathematics applies to mechanical systems. Like in chapter 1, right, we talked about the difference between the mechanical system, chemical system, and biological system. Mathematics applies to mechanical systems because mechanical systems are they're just externally unified. There's no internal teleological principle there, which cannot be, that's what can't be measured with mathematics, or can't be described by mathematics, is this purposeful activity of living organisms. And that's what is trying to be described with mathematics, and that's where a problem comes. But in mechanical systems, of course, measuring the mechanical system quantitatively, and measuring natural forces, how they affect the mechanical system. I mean, that is there, and that is valid. But then again, it's about recognizing the specific nature of a type of logic and where it's appropriately applied and where it's not appropriately applied. So the mechanical systems and computers, yeah, of course, we're seeing mathematics is very applicable to mechanical systems, and there's no argument there. But it's when it's inappropriately applied to try to describe living entities and the systems, the biological systems of the living entities, that problems start to come up. Dr. Gopal, did you have anything?
So mathematics is mainly for these external things for a soul. Like mathematics cannot measure the bhakti, or mathematics cannot measure love. So this mathematics, I think it will apply only for the external things, maybe something like that. As you told, like it's a mechanical one. So, and sometimes it's like in this material world, so some calculated thing, that's all, which this mathematics can be useful. But in the higher worlds, maybe this will not apply mathematics. So how can we say that? Because if I want to know the distance between one source to other source, we can take a bus or something to travel. We can have some idea on what is the distance. But in the higher worlds, we can present from source A to source B in 1 second. So these calculations may not apply, I think, there.
I think a big part of what Maharaj is trying to speak to by pointing out the limitations of mathematics is we've encountered several times on just even the Sadhu Sangha Google group that Srila Shanta Maharaj and Sripad Puri Maharaj contributed to for a long time, that some of these scientists and some of these materialistic philosophers are thinking that reality itself is a mathematical construct. And it becomes very abstract when you hear them try to describe what they mean by that. But they think fundamentally reality is a mathematical construct. And so what Sripad Puri Maharaj has also pointed out, it's not written in this part of the book, but he has mentioned it in some of his talks, is that when we just consider that, the fundamental unit of measure, right? When we're measuring things, there are units of measure. So then where does that unit of measure, how is that actually determined? Is the fundamental unit, is that like a physically existing thing? Or what is that fundamental unit? And essentially, you find that it's actually just an arbitrarily agreed upon social construct. The units of measure, even the most fundamental unit of measure, is just an arbitrarily chosen. There's no actual necessity or reason behind it, but then it's agreed upon within a given social context, and then that becomes the absolute standard. And then all the other units are, it's that fundamental units times 5, right? The inches, how many centimeters, and all these things, different metric units, all these things. But what is that actual fundamental unit? Is just something socially agreed upon. It's an agreement among people. And there's no absolute necessity for that. So then how can you say that reality is based on these, fundamentally, that even humans are reducible to mathematics, right? Because that's essentially what these people say, that even human beings, right? Everything a human being is fundamentally reducible to equations, right? Equations. And, you know, mathematics is the way that humans understand things. Like Werner Heisenberg's quote, right? Science is what we can say about nature, is not what nature is in itself. So mathematics is one of those methods of trying to describe things from our perspective. But it doesn't have anything to do with what nature is in itself. But that point is not understood by most scientists, most mathematicians, even materialistic philosophers. They're thinking somehow or other mathematics is the fundamental construct of reality. Things are just equations. I think
I have a point to mention.
oh yes.
This forum, what you have started regarding this, it's very, very useful for the scientists and certain mathematicians, geologists, and so on. Right now, the number of people who are there in the forum, it's like very few. Is there a way of bringing them all to this particular forum? Because what you're speaking makes a lot of sense and very useful for them. They should hear all this, apart from what we are, and they should actively participate. Is there a way of reaching them? Is what I'm thinking.
You're
For
saying
further classes, yeah, further
in
classes.
general, the scientists in general, you're saying?
No, right now, this classes, what you're doing, it sounds very interesting and very useful for those people also, other than whoever is there right now in the class.
Yes.
So, but the participant, those participants also participate.
Yeah, how to get them to come is what you're saying.
So is there a way of contacting them and getting them into this classroom? It's what I'm doing.
Well, you know, that's part of why we're all here also, is so we can hear these things and then we can present them to whoever you're in contact with, actually. You know, we try our best via the internet and who we come across in our daily life. Of course, Srila Shanta Maharaj has made the conference once a year. We try our best with the conference. So many email lists have been created in the past by Sripad Bhaktimadhava Puri Maharaj and Srila Bhakti-Niskam Shanta Maharaj. So that the effort is there, but that is why then when the devotees come and the devotees by Krishna's arrangement are in academia, then they have, you know, honestly, they have access to a whole network of people that are in academia, scientists, philosophers, educators, that we have not been able to speak to before. So then, you know, only by the grace of those devotees, if they can help to create those contacts, then that's how we can speak to them. And then we will be very happy to show them these things, tell them these things, present these ideas to them. But, you know, it's only possible by the mercy of the devotees if they can help with the service. It's very important, as you pointed out, but it's not possible unless more devotees take it seriously and contribute to the service. Dandavad Pranam, Uma Devi.
Hare Krishna, Dhanavad Pranam Prabhuji. Dhanavad Pranam Didi.
And I know it can be difficult sometimes because the people that need to hear these things most are the people who will be the most resistant to coming, and that can create awkward.
Exactly, what you said is right.
Yeah,
Yes,
of course.
the
That's
right. Because the moment I mentioned the same thing to one of my lecturer friends who are in the Department of Mathematics or zoologist,
Mm.
they will say we are very busy, we will not be able to make it, and so many reasons, and they'll be putting more resistance to join to these sort of forums.
Yeah,
You're right.
yeah. Of course, that challenge is there.
Yeah.
But anyhow, even with that challenge there, you know, in any service, there is always some resistance, whether it's coming from our own personal self or coming from the external circumstance. There's always some resistance or some obstacle to overcome in order to actually do the service. We're seeing that with many things, not just this kind of preaching. So that's all Krishna's arrangement. We have to see it like that. Krishna is the absolute. He is Ishvara, controlling everything. So he is controlling that we have been given this kind of service, and he's also controlling when the people that we want to preach to are giving resistance. He's also controlling that. So it's just, it's by his grace, whatever our sincerity is and our sincere conviction to do the service, no matter what kind of difficulty comes, this is all his grace to help us purify ourselves, actually.
Challenges make us stronger.
It's true.
So I have a question.
Yes.
What is the source of mathematics? Where did it start? How did it come to be? I mean, I could try to research it, but I'm not sure if
Mathematics
anybody.
is very ancient.
Yeah.
You see in the Western world, Plato, right? Plato, he has this analogy of the divided line, where he delineates the priority of modes of thinking, basically. Where at the very top, the truth is nous, or pure thought, pure thinking. That's what is most conducive to the truth, nous. And then underneath that, actually, he has the word dianoia, which is mathematics, because it, in his way of using it, it's something objective, some objective system, because underneath that then is opinion and belief. Is doxa and pistima, I think is called. So basically, Plato is also recognizing mathematics as something useful, although he put it underneath pure thought, because once you get to the level of pure thought, this dynamic organic activity of pure thought, or nous, mathematics can't touch that. But he did put it higher than just beliefs and dogmatic opinion, because mathematics does give some objective way to, measure. So Plato had like that. And of course, then the Pythagoreans were a whole group of Greek philosophers who thought, mathematics was very important. And then in India, also, there was many mathematicians in ancient India.
Aryabhatta. Aryabhatta was the one who gave zero. And then Ramanujam was also a famous mathematician.
Yes. So mathematics essentially is, again, is a mode of thought. So its actual origin is not something just historical. It's a level of consciousness. It's a way of seeing. It's more advanced in that the necessity of trying to be objective is there. Instead of just trying to be just whimsical and all over the place, some objective necessity is there with mathematics. So in that way, it's a little bit advanced. But then it becomes too rigid when we think that everything can fit into that. So then pure thought, as Plato and Aristotle saw, right? Aristotle saw noesis, noesios, noesis. So we said Plato said that nous this Greek word nous, thought is the highest principle of truth. And then Aristotle, Plato's student, came to say that God, or theos, is noesis, noesios, noesis, pure thought thinking about itself, thought thinking thought. So pure thought cannot be restricted to mathematical limitations, but mathematics is a product of thought. It's one way to think about the world, or one way to think about reality. So it's just like that.
Thank you. I just find it interesting that it's very difficult for people to agree on things, but yet mathematics is worldwide. I mean, is there any resistance to mathematics? It seems to be the one thing that everyone agrees on. I mean, like you said, 1 + 1 is 2. That's worldwide. It's not just here or there. It's everywhere. So,
Well,
but
again, it's not, we're not saying 1 + 1 doesn't equal 2, but the point is just to point out what, that's a type of logic, but what is it applicable to?
no, yeah, I understand that. I understand that. But I'm just saying that with all the discrepancies, with all the, I guess, the disagreements there are with people around the world, mathematics is the one thing that everybody agrees on. You know what I'm saying? The logic and the thought behind mathematics is the same around the world wherever you are.
Yeah.
But yet nothing else is that much, is agreed upon to that level, is what I'm saying.
Yeah, that's a good point. There are some people, we've seen some papers, and even this one individual who gave a presentation at the last conference, Perry Marshall, he also was showing that mathematics is not as is not what people think it is, essentially. I forgot exactly what he said about that. I want to go back and look at his presentation, but he was also advocating that mathematics is not the end all be it all. And so people are thinking about that. Sripad Puri Maharaj has been talking about it for a very long time. So he was, you know, when others start to realize it also is very encouraging, and it's nice.
I'd be curious to see what he said about it. So if
Yeah.
you can share that next week, that would be nice.
Yeah, you can take a look at that. Or here, I can just pull it up now for this last 15 minutes of our discussion, if that's okay.
Sure.
Um, So this is from his paper. This is the paper he presented at the conference. Biology transcends the limits of computation. Yeah. All right. So this is something I meant to mention. So when you think that mathematics is fundamental, to everything, that's the kind of premise that leads to the idea that artificial intelligence can, essentially replace humans also. So I think that's what he is addressing here. Okay. I've argued above that 6 major open questions in biology pose deep challenges to the prevailing reductionist model of science. As defined by many, starting with Descartes, the aim of this model is to reduce all behaviors of the physical world to logic and mathematics. This, if accomplished, was believed to make all the behaviors of the universe predictable and computable. The reductionist model has been challenged by post-Newtonian physics, yet it persists in the expectation that someday supercomputers will model all aspects of the cosmos. In biology, which has been said to be sophisticated physics and chemistry, and even in the social sciences, the reductionist or materialistic view is still widely held. A series of syllogisms, which follows in the next section, proves that the reductionist view violates the laws of logic itself. Statements come in 2 types. The first 2 are deductive syllogisms, which provide rigorous mathematical proof. The rest are statistical syllogisms, which are true based on the laws of information, entropy, and the second law of thermodynamics. However, an exception could be found for the latter. Statistical proof is less rigorous than mathematical proof, but all scientific laws exist in this latter form. So, without reading all of this right now, let's see what his conclusion is. So here he's making the same point that Sripad Puri Maharaj has made, which is well known, that mathematics is based on axioms, and axioms are just they're just base assertions, and then everything else is built off of that. Like we were saying about the fundamental unit of measure, it's something that's just agreed upon, and then once that is agreed upon, then all of a sudden it becomes the absolute foundation or standard, and everything else is built off of that and presented to be very objective, although it's built from something which is just kind of arbitrarily agreed upon. He said, axioms in mathematics are not computed, but must be chosen inductively. The celebrated mathematician Hermann Weyl said, without inventing new constructive processes, no mathematician will get very far. It is perhaps proper to say that the strength of modern mathematics lies in the interaction between axiomatics and construction. This was also supported by Enderton. Of course, our selection of axioms will be guided by the desire to reflect as accurately as possible our informal pre-axiomatic ideas regarding sets and classes. Conclusion. I'm going to try to just look at this one thing that he showed from the conference. The presentation he showed at the conference seemed to be a little more straightforward in the challenge he posed to mathematics. Yeah, here's what he said. It's impossible to reduce biology to mathematics. So this is just a summary conclusion of the paper, which it was a little hard to find where he said that in the paper. But yes, so this is the main point, right? Mathematics is not the fundamental reality. It's a product of cognition, and its utility is only relevant to mechanical systems. It is not relevant to biological systems. But modern science is trying to force biological systems into mathematical equations and describe it with equations, and it's not good. And we are trying to stop doing that. It's not logical. Here is a better method. We have to learn about conceptual thinking, seeing things in terms of the development of consciousness, not in terms of the development of matter, because matter itself is the materialism is a form of consciousness itself, an immature or undeveloped form of consciousness. So when we can learn to see things through the lens of everything is a development of consciousness, then mathematics, everything will find its proper place in that development. That's what makes it very holistic and all-encompassing and non-sectarian, that things find their proper place relative to the organic whole and relevant to all the parts of the whole when we can see them in that way as a moment of the evolution of consciousness. So thank you very much for bearing with us. It was a little difficult to try to talk about these things, but we are trying, and it's important, although it may be a little awkward at times. It's super important, and we can only do this service with, by the grace and by the, cooperation and help of the devotees. And we're praying that everything will happen in a way that is pleasurable to Krishna, pleasurable to the spiritual master. And what else do we say? Vancha kalpa tribhyascha kripa sindhu bhyevacha patitanam pavanebhyo vaishnavebhyo namo namaha. Om Gyanatimidan Hasya Gyananjana Salakaya Chakshur and Militam Yena Tasmai Shri Guruve Namaha. Dhanava Pranams. Jai Shripad Brajagopal Prabhu Ki Jai, Jai Srimati Devidasi Ki Jai, Jai Srimati Devahuti Devidasi Ki Jai, Jai Srimati Bhakti Therese Ki Jai, Nitai Gora Premanandi, Hari 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 Bol.
Haribol.
Jai Guru.
Okay, so Prabhu ki jai.
Jai.
Jai Guru. Hare Krishna.